Okay, so here we are. I think this is homework 3. Anyway, so again, we're gonna follow the homework format here as best we can. The purpose of this assignment, and I recognize that this one turned out to be a little tougher even than I intended, but the purpose of this problem was straightforward, at least to me, was I wanted you to work all 3 possible ways to describe a vector in 3D. So there's 3 ways that it can be described. The blue triangle's a position vector, like you're going from one point to another point, and then the last one is 3 angles. And they kind of each present their own challenges. Mathematically, the 3 angles is probably the easiest, although to me it's kind of the hardest to picture. But anyway, so I wanted you to kind of work through all these just so you'd have, a frame, a way to think about this. So I wanted you to have one spot where you just have it all figured out, so you could look at it later. But then also I wanted you to think through what these angles mean, etc. No one ever asked you to draw these. You're never going to have to draw these again. I'm not going to ask you to draw them again. Okay, so if you struggled with that part of this assignment, don't worry about it. The grading on this one will be very lenient. But what I want to just make sure is that you understand what these things mean. Okay, and so what I'm going to do is, we've got these 3 vectors, and what I'm going to do with them is I'm going to draw them all on their own axis because I want to be able to see them. So here's A, here's B, here's C. And I want to be able to draw them so that I can see them. I recognize that probably most of you all didn't do that, but that's just a good idea to me. Okay, oh, well, we lost the A, B, and the C. Okay, well, whatever. Okay, so here are my axes here. And let's see if I can do my givens real quick. I'm going to do them above this. So given for A, let's see, the magnitude of A is 60 newtons. Okay, and it's going from the origin to, so it's going from the origin to negative 350, negative 200, 1,000. Okay, and all those have units of meters. Okay, now for B, magnitude of B is, where's B? 80 newtons. Okay, and then it's got angles, which are a little bit annoying, right? Theta Z equals negative 30, hachi-machi, degrees, and phi, or phi, I don't know, 20 degrees. Okay, and then this last one, C, has a magnitude I can't see right now. Oh, there's 100 newtons. So 100 newtons. Okay, and then theta X, theta Y, and theta Z, okay, is 120, 40, and 66.2 degrees. Okay, now I'm going to do those on 3 separate plots just for clarity. Okay, you could have done them however you wanted to. Okay, so what we want to know is we want to draw, okay, so required, oh no, I messed this all up. All right, anyway, required, I didn't give myself enough room. So required, we will draw them. That's A. B, add them. And then C, magnitude. Magnitude of resultant. Magnitude of resultant. Okay, so a lot of times that's just called capital R or something along those lines. All right, so then we're going to go down here and let's start. Okay, so the first thing I want to start with before I really get into this, I don't think Jeff really talks about this very much, but something to consider is that your normal axes that you normally play with, here's X, here's Y. Now where's Z? Okay, now a lot of people don't really think about this, but there's always a Z-axis there. It's just that for your normal problem, the Z is always 0, and it's just always in the XY plane. But however, Z is either coming out of the page towards you or it's going into the page. And so you have to, so you need to think about that. And the way that we do this is with what's called the right-hand rule, okay? And so basically what's going on here is your fingers are going this way. So this is your fingers. Okay, your palm is going this way. It's going that way. and your thumb, so if this is your right hand, so if you do that with your right hand right now, let's zoom in on this. If you do that with your right hand, you're going to notice that your thumb is sticking out towards your face. Okay, so that means that your thumb is, so Z, positive Z is up out of the page. Okay, now the other cool thing is if you look at what your fingers are doing when you've got it in that position, is your fingers are curling this way. Okay, so that curl right there, that is a positive angle. Okay, so that is a positive, well, it's a positive angle, I guess. So basically counterclockwise is positive. Counterclockwise is positive. Okay? So that's key. Now the other thing to remember is what makes it kind of confusing is if you were looking at this, if you were on the other side of this page, like if you were under the page and you were looking up, that would look like clockwise. Okay, so it's important to kind of think of your hand and whichever way your thumb is pointing, your fingers are going to tell you which way that thing is curling for a positive. Okay, so with that in mind, we're going to go down here, and when I name these axes, there's a correct way to do it. Okay, so if I decide that this is x, which is what I'm going to do, and I decide that this is y, then I have to think about where is z. Is z up or is z down? Okay, now based on what I just told you right here, it should be obvious. Okay, but if I put my fingers towards x and my palm towards y, you'll be able to see that my thumb is going up this way to z. Okay, and if I wanted to think about something twisting around that z-axis, okay, positive would be this way. Okay, so because that would be the way my fingers would be curling for that thing. Okay, so that's just something to consider. So if you want a right-handed coordinate system, it's got to be x, y, and z. Okay, if I had drawn it with z down, it would be a left-handed coordinates. Left-handed coordinate system, which, I don't know why they chose this coordinate system, but that is the one that they chose. Okay, so that's the one we're going to use. Okay, and this one down here, this is going to be for the resultant. Okay, so we got x, y, and z. All right, so let's go over here and let's start working. Okay, so we've got 60 newtons, and it's going from 0, 0, 0 to negative 350, negative 200, 1,000. Okay, so I've got a handy dandy straight edge, and we got to remember, so we're going to start here, and x we're going to negative 350. So let's go, let's say this is, let's say this is 100, so this is 200, this is 300, this is 400, so this is negative 350 is about right there. Okay, and then we're going to go negative 200 in the y, so that's harder to figure out where that might be. So let's say that's like right there. And then, so here's my y point, here's my x point, and then my z point was what, 1,000 meters. Okay, so we're going to go 200, 400, 600, 800, 1,000. Okay, so I've got those 3 points right there. Okay, so what I'm going to do, and you could do this however you want to do it. I'm going to draw a projection parallel to y here, projection parallel to x here. Again, I know my drawing is not going to be perfect. I don't expect perfect. I do expect to use a straight edge, though. Okay? And so now we're going to go up from there, whatever this 1,000 is. So it's going to go up to a point like more or less like right here, I think. Okay, yeah, that looks about right. Okay, and if you wanted to ascertain that was true, we could draw this one going up to its 1,000, like right up in here. And then we could box this all in and make it look all pretty and whatnot. Nothing wrong with a little beauty in this world. Right? So, kind of, right? Not quite. Oh, I've got a low battery. Not quite, right? So this bit right here is actually coming out a little bit. So, like that. Nope. Wrong thing. Anyway. All the lines are parallel to the axes. Okay, so here we go. Okay, so that's basically how we would draw where this thing is coming out. The hard part for these things always is making sure that your projection lines are parallel to axes. Okay, that's really important to make the drawing look right. Okay, so anyway, so now we've got that. So this is probably, in my opinion, although I suppose everybody's brains work a little bit differently, but to me this is the easiest one to draw. Okay, so this is where it's going, to this spot right up here. And maybe I'll pick another color. Maybe I'll pick this nice blue. And we're going from the origin to there, okay? I guess I could have made it not the origin. That would have just been unnecessarily complicated. Okay, that would have been like, Wagner would have been like, I think y'all aren't doing enough other stuff this week, so I'm gonna just take up your time. Okay, so that's the vector. Okay, so now we need to, we'll go one at a time with solving for it. So, okay, so we've got, so basically this is vector A. Okay, and the way that we always do these, okay, is we're going to go, okay, so A equals basically the magnitude of A, okay, which is given, times the direction that it's going, okay? And I always do these the same way. So basically, okay, let's do this position vector here. What do we call that position vector? I don't know what we call that. Let's call this the origin. Let's call this O. And let's call this the point, oh geez, I don't know, P, because it's right after O. Okay, so let's do our position vector real quick. So OP has a magnitude of, okay, so we're going to go the square root of its x displacement, its y displacement, and its z displacement. Okay, so we're going to add all those up, okay, and this is just the Pythagorean theorem. Okay, so how much did we go in x? Well, in x, we went from 0 to negative 350. So technically, so 350 minus 0. So we went, or yeah. So we went over negative 350. I'm not going to actually write the negative sign because we're squaring it. Okay. And then for the y's, okay, again, we have to compare the y locations. This one's a little easier because we're going to the origin. But it goes over negative 200. Again, I'm not going to write the negative sign because we're squaring it. And then for the z, okay, so we're going to go from here to here. And again, I'm not going to bother subtracting because it's just a 0, and I'm not going to worry about, well, it's positive, so I don't even have to worry about a negative anyway. Okay, so that right there is the magnitude of the position vector. Okay, so it's 1,078.2 meters. Okay, notice I'm keeping 5. Ideally, you'll just keep it in your calculator, but keep at least 5 through the whole problem as you're working it so we don't end up with any silly rounding errors. Okay, so the reason that I like to do it, I'm just kind of doing that on the side, because what we're going to do now is this A vector is going to be that times, what do they call it? I think they call it something like lambda OP. So basically it's a unit vector going in the OP direction, right? And so the way we're going to solve this is we're going to say that A bar equals, let's see, this is 60 newtons, okay? And now we're going to do for each of these is in the I direction. It's almost like a percentage, but it's not a percentage, but some portion of this. So 350 out of 1,078.2, okay, 350 meters divided by 1,078.2 meters is in the I direction. That's a negative. Okay, minus, because in the Y direction we also have a minus, right? It's a minus 200. Okay, minus 200 meters out of 1,078.2 meters. Okay, notice I like to keep the units in there because they're going to cancel out. And then we're going to add 1,000 meters times 1,078.2 meters. Oh, this needs a J. And this needs a K. Okay, and a lot of times they'll have a little arrow. I guess to be consistent with these arrows, we'll use an arrow. Okay, so let's use arrows instead of hats. Okay, I don't think it's not really important, but it's important that you're consistent. And I am not very good at doing that. All right, so then A then equals. All right, so multiplying that all out, we get this these fancy numbers right here. This is an intermediate step that we might want to keep, so I'll go ahead and box that. Actually, I guess since this is an answer, we should go ahead and present it in with 3 sig figs for the answer board. But the box one is the one we're going to work with. Okay, 55.6K. Oh, see, I'm really bad with that. Okay, so let's go ahead and put that right there. And we're going to put newtons. Okay, don't, always be careful. Remember sig figs and units. Okay, so there you go. So that's A. We're going to work with this one, but this is the one that we're reporting. Okay, so so let's go to the next bit. Okay, because obviously the C part of this problem we can't solve without doing doing each of these individually. One thing to note that if you're like look at this and you're like I don't know that this makes any sense, you can always do Pythagorean Theorem here, and you can square this one and then square that one and then square that one, and then take the square add the squares and then take the square root, and in this case the square root should be 60, right? Because that's the magnitude. Okay, so just something that you can always do. Okay, so let's go over to this one. This is probably the hardest one to me. B equals 80 newtons. Okay, that's easy. And then theta z, and then phi equals 20. Okay, so let's see what this means. Okay, and actually, now that I'm thinking about this, I think I did this wrong for some of you guys who called and asked me. No one will ever give you a negative phi. Okay, they're always going to draw this for you. Okay. We did give you, a negative theta z. Now we've got a positive phi. Now which way is a positive phi? Well, a positive phi, well, if here's the x-plane, right, here's x right here. Well, x, we're going to go in the positive direction. So remember what I was saying earlier about, so if you point your thumb in the z direction, okay, which way is positive? Which way are your fingers curling? Well, your fingers are curling this way. So positive phi, when you're curving off of the positive x-axis, is going to be this way. Okay, that's that swing angle. Okay? And so we'll call this 20 degrees. Okay? Okay, now, and this is like super weird, tricky business, right? Is what is this theta z negative 30? So theta z is the angle with respect to the positive z-axis. But which way are we going? We're going negative 30. Well, which way is negative 30? Okay, so here's how we're going to do this. Okay, so what I want you to do is I want you to imagine, okay, there's a plane between this dotted line and that z, and that is a plane that is kind of hard to see, but it is there, okay? And so when we turn in off of z, we're going to be turning in that plane. So either we're going to turn off of z towards, I guess we want to call this our positive swing angle, or we're going to turn off of it towards our negative swing angle, right? It's not going to ever hit x. It's not ever going to hit y. I mean, it's kind of, and I'm not a perfect drawer here, but it's going to come down, and it's going to end up above. Like if it was 90 degrees, it would end up all the way down on the dotted line. But would it end up on the, this dotted line, or would it end up on this dotted line? Okay, if it was 90 degrees or negative 90 degrees. And so the way to figure that out is, well, I don't know. I've been thinking about this a lot, and thinking about it pretty hard, but I don't really have a good way. But there is a way to do this where you would define it based on which way your thumb is going. But the problem in this case is your thumb. If we're turning in the way that we are, the thumb is actually going on an angle. Like it's coming out this way or it's going this way, and I don't know which of those two ways it is. I don't really know how to answer that question. Okay, so really any answer in this case is correct. The way that I would typically think is I would think that this was positive because moving towards your dotted line over here is kind of typically the way we think about these quote-unquote blue triangle problems. So I'm going to go ahead and make this negative. Again, I'm going to grade this really, really leniently. Yeah, so we're going to grade this leniently. And that's totally fine. Like there's nothing wrong with that. So what we'll do is we'll go up this way. We'll end up at a spot like right here. Okay, with this angle off of the z-axis being, what did we say? 30 degrees. Okay, now it's no longer negative because I went ahead and drew it, right? Okay, so now where's the blue triangle? Okay, well here's the blue triangle. The blue triangle looks like this. Okay, and so here's the blue triangle as it's so called. Okay, this is a right angle right here. I'm going to make the right angle red because why not? There's the right angle. Okay, and that's the blue triangle. Okay, now I mean you could have drawn one on the other side, and I would have accepted that as well. Okay, so this bottom line is in the XZ plane. This one's in the XZ plane, and this one is just going straight up in the Z direction. Okay, so and so this is B, right? And we know its magnitude, so we know the magnitude of B, which we gave up here as 80 newtons, and we know these two numbers. So let's go ahead and break this thing down. Okay, so what I'm going to do is I don't want to work with 30 because I just want to work with this 60 right here instead. Okay, I could work with, this. I could work with this as 30. It doesn't really matter. Okay, either one that you want to work with. Let's work with the 30 because it's given. Okay, well, we don't need to erase that. All right, so I'm going to take this 60 newtons here, and we're going to do some trig. Okay, so let me get rid of this B and just write 60 newtons. Come on, you can do it. Computer's being really slow right now. 60 newtons. Okay, that is what it was, right? 60, 80. 80 newtons. Okay, I didn't screw that up over there. That was 60. Okay, this is 80. All right, so down here, okay, so what I'm going to do is I'm going to figure out the sides of these triangles. So I want to figure out this vertical side of this triangle right here. Okay, and that, of course, this is B in the Z direction. Okay, so the way we figure that out is I'm going to start thinking about my trig identities. I know the hypotenuse of this triangle. Okay, and I'm looking for, this is the adjacent to that BZ. So I'm going to go ahead and say, okay, so adjacent means so that's cosine. So the cosine of 30 degrees equals BZ. Okay, that's the adjacent over the hypotenuse, which is 80 newtons. Okay, so if I solve that, I get 69.282. Okay, newtons. All right. And if I wanted to, I could turn that into a direction thing by doing that and just saying, well, that's in the K direction. Okay, if I wanted to, that would be totally fine. Okay, again, keeping 5 significant digits. All right, now I'm going to go ahead and get this bit down here. Notice this bit is in the XY plane, so it is neither BX or BY. I'm going to call it BXY because it's in the plane. Okay, and nicely here, like, I've already done the cosine, so I'm going to do the sine of 30. Okay, and this is going to be B, so this is opposite, so the opposite side equals B XY divided by the hypotenuse. Okay, so COA, 80 newtons. Okay, so BXY equals, and I don't know why I paused for that, but anyway, 40 newtons. Okay, and we're not going to give that a direction yet because we're going to leave that as a magnitude because that's going to be easier. So then what we want to do is, so now I've got BXY, okay, so that's 40 newtons, which is a nice easy number to work with, luckily. And so I'm going to go ahead and label that over here, 40 newtons, because I need to draw another triangle, right? So here we go. And I'll draw this triangle in green, right? So basically, we're going from that point in the X direction. We're going to drop a line. Oh, dropping a line. All right, going that way. So now this is our triangle. Okay. And remember that this line that I'm drawing right now is in the Y direction, and this one is in the X direction, which tells you that this is a right angle right here, which is great, right? The other thing we know is that I'm running out of colors here. Red, I guess, is that right here, this angle, okay, that's 20 degrees. Okay, because that was our swing angle. And this angle right here is also 20 degrees. Okay, and we know the hypotenuse here. The hypotenuse is 40 newtons. Okay, let me zoom all the way in. Okay, so if we've got that, then I can start figuring out these sides, right? So this is b in the y direction, and this is b in the x direction. Okay, so I can do a little trig here. And it's going to be little because when I zoom out, it's going to be really tiny. But it doesn't look like a right triangle, but it is a right triangle, right? So I've got this 20-degree angle. And if I want to deal with by first, well, that's a cosine because that's the adjacent. So we'll do, let's see here, cosine of 20 degrees equals the adjacent by over 40 newtons. Okay? Okay, so that's the adjacent over the hypotenuse. And then the sine of 20 degrees, okay, equals the opposite, bx, over 40 newtons, okay, because that's the hypotenuse. Okay, so if we solve these, now I've got by and I've got bx, okay? Okay, so we get some, some numbers. And then what we want to do is we want to put i's and j's on these, okay? So let's see here, x gets the I, okay, and y gets the j. Okay, now let's see, are any of them negative? Okay, that's an important thing to think about here. Let's see here. The y is negative and the x is negative. Okay, so we're going to put some negative signs on there. Okay, yeah, they're both negative. Okay, so we're going to go negative in the x and negative in the y. Okay, so our final answer here then becomes, I wonder if there's any way I could like copy and paste that. Let's just go ahead and let's do it right here. So b equals, in the x direction, we get negative 13.681 newtons. Oh, let's keep the newtons out of this for now. Right, that's going to be our I. Minus 37.588. That's our j. And then our k, this is really big down here. Where's our k? 69.282. 69.282 K, and that is newtons. Okay, so there's our B. Okay, and then the part where we're going to report it is going to look like this: negative 13.7 I minus 37.6 J plus 69.3 K. Okay, and then we'll put a little newtons on there. So this is the one that we report. This is the one we're going to work with. Okay, that way we don't have any rounding errors. All right, cool. All right, that one is pretty small by comparison to that one, but anyway. All right, so C. Okay, so we got three angles. This one to me is always the trickiest one to draw. Theta x, theta y, theta z. So theta x, we'll notice, is over 90. That means that theta x is going to be, so if theta x were 0, then that means it would be on a right angle with x, and it would be in the xz plane. However, it's greater than 90. So it's actually in a negative x space. Okay, right? So it's not on this side of this axis. It's on this side. It's over here, right? It's over here somewhere. It's on this side of the xz plane. Okay, so that's interesting. Okay, note that these other two, these are less than 90. So because they're less than 90, they're in the positive y and the positive z plane. Okay, so let's see here. So the positive y plane, that means it's over here or here or, here, right? And then the positive z plane, meaning it's kind of upwards a little bit, okay? So, oh wait, no, it can't be over here, right? Because we said it has to be in the positive xz plane. So I don't know where this is going to end up. It's pretty hard to draw this or to kind of visualize where this might be. I'm going to pick a point. Let's see, it's closest to the y-axis because it has the smallest angle there. So maybe I'm going to put it right in here somewhere. Okay, and we're just kind of making this up, really. That makes theta z look very small, though, doesn't it? Okay, let's put it down here. Okay, this is the hardest one to draw, in my opinion. And basically, if I were ever to ask you to draw this, I basically have to accept whatever it is that you turned in. Okay, so this, then that's 120 degrees. Okay, that's theta x. the theta y is 40 degrees, and the theta z is 66.2. Okay, so kind of hard to draw and even picture what all this means. I don't really have a lot of answers for you there. Actually, I do have some answers, but it's after you solve it. Okay, so, and I'll show you that in a second. Okay, so we'll redraw this after we solve it. Okay, so this is actually the easiest one to solve, because for each one of these, basically what you're doing is you're saying, well, here's my axis, okay, and here's my, 100 newtons, and then here's theta axis, right? Something, I mean, it could be x, y, or z, right? And so what we're doing here is we're just going to like drop this line right down there. Okay, so the formula for this becomes almost like childish. Like let's make this more generalizable, and let's just call this C, because that's what we're working with here, C. Okay, so C becomes, like in this axis direction, let's say that's the x direction, it becomes the magnitude of C. Magnitude of C. Well, let's go ahead and let's do the trig here. Okay, so we want the cosine, because we're trying to get how much of this is going in that axial direction. So we're going to say the cosine of that angle, theta axis, equals the magnitude of C. No, that's not right, is it? Equals C in that axis direction. C in the axis direction. Okay, because that's my adjacent over my hypotenuse, which is going to be the magnitude of C. Okay, so if we rearrange this, then I can say that C in an axial direction, in any axial direction, is C times the cosine of that angle. Okay, so that's what we're going to do here. We're just going to repeat this 3 times in all 3 directions. Okay, so we've got, so C equals, in this case, what would we say, 100? 100. 100 newtons, okay, times the cosine of, what was it in the x direction? 120. Okay, plus 100 newtons times the cosine of theta y, 40. Okay, and that's in the j direction, plus 100 newtons times the cosine of 66.2 degrees K. Okay, now I put pluses on these. Yeah, and the pluses will take care of themselves. Okay, because this C is going to give me, this one's going to give me a negative number, because that number is greater than 90. Okay, and in fact, that's a 50 newtons in the I, plus I'll have to use a calculator for the other two. Okay, so notice, there you go. We check our signs. We got negative, positive, and yeah, so everything looks good. This is the one we're going to work with. The one that we're going to report, though, we're going to round to 3. So negative 50 in the I, plus 76.6 in the J, plus 40.4 in the K. Okay, and we always want to make sure that we have units, so newtons. Okay, so there you go. That's the one we report. We're going to work with this one. All right, so what we need to do now is we need to gather these results in one location. Where will that location be? Hopefully somewhere down here. So let's go here. Let's see. Well, I'm just gonna like pause it and come back. I'm gonna gather them all together, and then So there might be a little jump here. Okay, so before we get too far into this, and before I start really playing with, I've gathered up all of my information. But before we start doing all that, I want to talk about, if ever anybody needed you to draw this, and you had theta x, theta y, and theta z, and you're like, well, how do I do this? Because obviously what I just did right here is quick and dirty and probably not all that good. So what I would do is, if I needed to do this perfectly, is I would calculate this first. Okay, so I would go out of order, right? So I would go like this, and I would make my x, y, and my z. Okay, I'm not using a straight edge here just because I'm trying to be really quick and dirty. Okay, so here's x, here's y, here's z. Okay, and so what I would do is I'd say, okay, well, I'm going negative 50 in the x, let's go out to maybe there. Positive 76.6 in the y, so maybe we're going to go out to, I don't know, it looks like we're maybe about here. And then 40.4 in the j, so maybe that's like right in here, right? So, you know, again, I'm doing this kind of quick, like that. And then I hate when they end up near the axis. Anyway, so then up to like, I don't know, here. Right, so now I draw this in blue. I don't know why I'm getting a straight edge for this because the rest of this is so sloppy. But there you go, right? So that's how I would draw it. And then, you know, and then you'd go, okay, well this theta x, this is 120 degrees. Okay, theta y is, I don't remember, 40 degrees, I think. 40 degrees. And theta z is 66.2 degrees. Okay, pretty hard to see, right? Because theta z looks really close. And it just happens that it isn't. Okay, you know, so that's, if ever I needed to draw it really well, I would get these components first. Now I might draw it from a different perspective than, you know, maybe I would draw my axes like this. That might make it a little bit easier to see where it is if I did x, y, z. You know, kind of spin it around a little bit. Anyway, neither here nor there. All right, so over here, we're going to kind of try to figure out the third part of this problem, which is what is the resultant of these three if I add them all up. Okay, so the resultant is going to be a plus b plus c. Okay, so I like to line them up like that just because, you know, I don't know, harkens back to like, you know, first grade or whatever, you know, whenever it is that you do this. So we're just going to add these things top to bottom. All right, so yeah, so you just add them all up top to bottom. The i's go with the i's, the j's go with the j's, the k's go with the k's. Now, I already made a mistake. What was the mistake? I don't expect too many of y'all to notice this, but because you all are not as type A about this as I am, but I wish that you would be, is that these need units, okay? We're not working with numbers here. We are working with a quantity of force, okay? And that's important. Okay, so the last part of this problem, it asks for the resultant of this, you know, the magnitude of the resultant. Okay, so that can either be written as just a capital R, you know, or a lot of times books will bold it, although I usually try to remember to do this, okay? And, you know, it basically equals, I'm not going to bother with the negative signs because they're getting squared. 27.886 newtons squared plus 165.29 newtons squared. Okay, I always keep my units. Okay, except when I mess up. Okay, so let's go ahead and plug that in and we'll see what we get. Okay, so we get what looks like 187.12 newtons, or, you know, for reporting purposes, 187 newtons. Okay, notice 5 significant digits here, and there's 5 in all of these numbers. I kept 5. I worked with the version that had 5, not 3. Okay, if I wanted to draw this sucker, okay, we would go over here and we would say, well, negative 83.158, so maybe that's 1, 2, 3, 4, and a little bit blocks in the x direction. That to me, okay. And then, sorry, 27.866 in the j direction. So maybe that's, you know, I don't know, maybe about right there. And then 165.29. Let's see, 1, 2, I'll say 20, 40, 60, 80, 100, 120, 140, 160, 165. Okay, so we're off the charts here, but that's okay. Okay, so then, you know, so we're going to draw our little lines, and they're going to be parallel to the axes here. All right, and we're going to go up really a long ways, in fact. Okay, so I'm going to go vertical till I'm, I don't know, roughly like that, right? More or less. Okay, how will we know? Well, this is how we'll know. If you really want to know, if you really got to know. All right, so it's going to be like this. All right? And this one's going to feed back into that y-axis, that imaginary y-axis. Right, so you come all the way down this way. Right, and so obviously z would need to be extended a little bit. Right, so we take a little blue, and we go, oh, it's going to a point out here. And from there, we could back calculate those theta x, theta y, theta z's. Those would be easy. To get to a location, I don't know, it's kind of trivial or not important. I would never want to do that. So from there, you could back calculate to one of these if you wanted to, although it's kind of something you would never need to know. These are algebraically easy because they work with this formula. So if you want to do theta x, theta y, theta z, and then the blue triangles, I can't imagine ever wanting to go backwards to this. Okay, I just can't see it. Okay. So anyway, that's 41 minutes of me babbling, and there's a lot to keep track of here, and I could easily imagine, that there's a careless error in here, okay, and be easy on me, okay. But the concepts and the ideas here are correct. Again, like I said, you'll never see this. You're never gonna have to draw this. So usually, what's gonna happen is it's gonna be given to you. Just make sure that after you draw it and after you start working it, you start thinking about the signs. Think about whether or not this is in the positive x, positive y, positive z, or negatives, right? Because those are just careless errors, and it's just like a little nickel and dime. It's like a little bit here, a little bit there. As your instructor, I have to take off, but it doesn't make me happy, right? And so the goal here is that through time you'll become less error prone. I mean, if you watch me, you'll see I still make the errors. We're never going to be perfect, but usually we end up doing these things 2 or 3 times to make sure we get it right. On a test, obviously, we don't really have that time, so we just do the best we can. All right, so anyway, that's how we do this problem. Oh, well, let's go up to the beginning and make sure we did everything. Where's it given? And where's it required? Okay, did we draw them? Yeah, we drew them. Did we add them? Yeah, we added them. Did we get the magnitude? Yeah, we got the magnitude. All right, so we did everything. Sweet. All right, guys, take care of yourselves. Just remember, school's important, but you're more important. All right, take it easy. We're all in this together. Help each other, love each other, be excellent to one another. All right, bye. None of that.